class, right? That is the formulas are D is equal to Ks plus C if we want to measure the distance in case of your horizontal line of sight. Then we have seen your multiplying constant or additive constant, that is a C, right? That is C is equal to F plus D, right? Or we have determined it by replacing it Ks plus C. We have find out the correction factor C is equal to D1 S2 minus D2 S1. Then K we have determined it by using the formula, right? We will be determining by using the formula D2 minus D1 divided by S2 minus S1. Okay, so this is what we have discussed in the previous class. Now, today we are going to discuss regarding the inclined line of sight. Okay, we are going to how we are going to determine the inclined line of sight that we are going to study in our today's class. We are going to see both two conditions, that is if the line of sight is having inclination or declination. That is the two things that we are going to see in our today's class. Okay, so we will be seeing in our today's class regarding the if the line of sight is inclined, how we can measure the distance and the elevation by using if the line of sight is inclined. Now, before having the line of sight, what is we should know what is inclination, right? I have already told in the previous class, but still I will just explain what is your inclination or declination is. So this is your staff. Okay, this is your staff, and then this I'm having a theodolite over here. If I place my theodolite like this, that is the line of sight is horizontal, right? If I make it my telescope like this, right? If I make my telescope like this, then it is an inclined line of sight, right? It is an inclined line of sight. When it was straight, the line of sight was like this, horizontal line of sight. When I do the inclination, it will be having the elevated angle, right? And what is declination? Declination is looking towards downward. If I have the telescope towards the downward side, then it is nothing but it is the angle of declination. So this is horizontal line of sight. This is horizontal line of sight. If I place my telescope in a horizontal direction, this is inclined line of sight, right? And this is declination, the angle of declination. So this is declination, this is inclination. Okay, so this is what the angle of declination or inclination is. Okay, now in this we will see what are the different things are there, right? Here we are going to have the instrument station P, that we are going to set the instrument at a position P. Okay, we are going to set the position, we are going to set the instrument at point P. Okay, this is your instrument station. Now, and M be the your position of the instrumental axis. So this is what your center point or the Trunnion axis of your instrument, and this is what your M is nothing but your position of the instrumental axis. That is, M is the point of Trunnion axis. Then we will see ACB corresponding to the readings of the three crosshairs. So when I place this particular instrument in an inclined position, so from here, this is the exact center point of your Trunnion axis or your center point of an instrument, right? I will be looking here the staff A and staff AQ I have placed it, right? So A is the top point, Q is the bottom point of your staff, right? And I will be looking from M, I will be looking in the inclined line of sight. So I will be looking towards the staff. So it is in the angle of inclination. Okay, so A, C, B are the points corresponding to the readings of the three crosshairs. So A, C, B, right? So A, C, B are nothing but here A, C, B are the readings of the crosshair. Okay, these are the reading of the crosshair. I will be, if I look from this point, I will be in staff. If I look, these crosshairs, that is upper and lower stadia readings, will be reading A and B, and the crosshair center will be reading the point C. Okay, it will be reading the point C. So this is regarding your what is an angle of inclination. From M, I will be looking towards the staff, which is present at a height. It is present at some height, right? So I will be, the stadia hairs will be having the readings at A and B, right? And your crosshairs will be reading at the center C. Okay. Then we will see what are the different nomenclatures we are going to have. So ACB is clear. S is equal to AB, that is staff intercept. Now we will see A and B, this particular distance between A and B, we call it as a staff intercept. Then we are going to have theta, it is an inclination of the line of sight from the horizontal. Theta is nothing but, this is your Trunnion axis. From this is your telescope, right? From the center, or from the center point of your crosshair, right? Whatever the angle it is going to make with the horizontal, that is we are going to measure as theta. With the center, or the center of the crosshair, right? With the crosshair, whatever the angle it is going to make with, right, the horizontal line of sight, that we call it as a theta. Okay. Then L is your length MC is measured along with the line of sight. M is nothing but your Trunnion axis, and C is nothing but your center point of your crosshair. So this MC, it is equal to L. L is equal to M into C. Then we will see D is equal to MQ dash. D is nothing but the distance, right? Horizontal distance between the instrument and the star. MQ dash, D is equal to MQ dash is nothing but, right? This D is nothing but MQ dash. It is the horizontal distance between the Trunnion axis and your line of sight. Okay. Now, the horizontal distance between the instrument and the staff, that is horizontal line of sight and the staff. Okay, so that is what your the distance between D is equal to MQ dash. Next is V is equal to vertical intercept at Q between the line of sight and the horizontal angle. Vertical V is nothing but, this is what your vertical, where this particular distance V is nothing but, it is the center point of your cross staff reading, and it is with the horizontal line of sight. So this is the center, from the center of your crosshair, right, and with the horizontal line of sight. So this is nothing but the distance, vertical distance V is. Then H is nothing but, it is called as V, this particular thing from the point P, we call it as the height of the instrument. We call this as an height of instrument H. Okay. R is nothing but the central hair reading. Now, this is from the base of the staff to the crosshair, whatever the reading we are going to take it, we are going to read it as R. Okay. Next is angle beta, the angle between the two extreme rays corresponding to the stadia hair, right? So now this beta, right, this particular beta is nothing but, it is the angle between the two crosshair, right? It is the angle between the two crosshair readings. So this is nothing but your beta is. This is nothing but your beta is. Okay. Then we will have beta is clear, R is central hair reading is clear, Q is nothing but the staff station, we already know it, right? Q is nothing but your staff station, this is your Q, and O is nothing but the optical center of your objective, which is over here. Then I is nothing but the stadia interval. This I is nothing but your stadia interval, okay, which is going to come over here, the stadia interval I. Okay, next we will see, we will go to the interior part of this particular problem, where or your line of sight is having an inclined position. We are going towards that point. Now we will see, right, from the angle, right? From the angle, draw a angle, right? It is here from the angle A dash C and B dash C, right? Which is approximately, we can take it as equal to 90 degrees. Now we will see A dash C and B dash C. A dash C, right? A dash and C, here it is going to make an angle 90 degrees approximately, and B dash C is approximately taken it as 90 degrees. Here we will see B, right? B dash C, it is approximately, it is 90. I am not telling it is equal to 90, but it is approximately, it is near to 90s. Okay. Now here from the triangle AC, now here it is telling approximately equal to 90 degrees. So A dash C is equal to angle B dash C is equal to nearly is equal to 90 degrees. From the triangle A C A dash, A C and A dash, from the triangle A C A dash, right? And right, A dash C is equal to A dash C is equal to AC cos theta. Okay, so see all these things we want these final equations, right? But we need to know how we have brought it or how we have got it. Just we need to know that, right? So this particular thing and this particular thing will be important for us, but still we will be knowing how we have got this. So from AC triangle AC A dash, we have got A dash C is equal to, that is your A dash C, right? Just a minute. A dash C is equal to, we are going to get AC cos theta. We are going to get AC cos theta. Then A dash B dash, that is this, right? A dash and B dash, we are going to get it as AB cos theta, right? We are going to get AB cos theta. So AB is nothing but, A and B is nothing but your staff distance, that is S. So it is S cos theta. Okay. Then we are going to, since the line A dash B dash is perpendicular to the line of sight OC, since A dash B dash, A dash and B dash, it is perpendicular, since it is making the line perpendicular to the line of sight, right? It is making the line of sight OC. The equation D will become equal to, as we know that from the line of sight, this particular distance D will become is equal to Ks plus C, right? So now MC is equal to, that is this particular distance M and C, right? We are going to measure the length L and C is equal to, right? K S is nothing but your K A dash B dash is nothing but your S, that is staff interval, right? A dash B dash is nothing but your staff interval, right? Plus C is equal to, right? Here it will become A dash B dash is nothing but equal to, right? It is S cos theta. So K into S cos theta plus C. Okay. Now the horizontal distance D, this particular distance D will become equal to L cos theta. But what is L? L is nothing but it is Ks cos theta, right? It becomes L cos theta. Then what is L? L is equal to Ks cos theta. So here it is already cos is there. So it will become cos square theta plus C. Okay. Plus C. So here again C into cos theta is there. So it will become C cos theta. So distance in case of your inclined line of sight, we are going to use the formula. In case of your inclined line of sight, we are going to, my screen is visible to you all? Yes?
Yes, sir.
Yes, sir.
Just a minute, in my mobile it is not. Just a minute. In my mobile it is it clear? Is it visible? In my mobile
Yes,
it is
sir.
not visible to me.
Sir.
Yes? Is it visible
Yes, sir.
completely?
Yes,
Yes, sir.
sir.
Visible,
Fine.
sir.
Fine. No problem. Okay, so there is a little bit network issue is there, so that is the reason why probably it is happening. So here we are going to get, right? Here we are getting it as distance D. Okay, distance D, right? In case of your inclined line of sight, this distance d is becoming, right? We are going to use the formula ks cos square theta, right? Ks cos square theta plus c cos theta. Okay, so if we want to measure the distance d, we will be using the formula d is equal to ks cos square theta plus c cos theta. So this formula we are going to use if we want to have the measure the inclined line of sight. Okay, next is we want v, right? We want the vertical distance v from the horizontal line of sight. If we want v, how we can calculate is we can calculate it by using the form L sine theta, right? We are going to calculate, right, by using L sine theta. Now L we have already determined it, that is ks cos theta. From this particular thing we have already got it as, right, L sine theta. So L cos L, right, it will become, right, L is nothing but ks cos theta plus c, right? So it is L is nothing but ks cos theta plus c into sine theta. So totally it is becoming, right, ks cos theta into sine theta. So if you simplify this, right, we are going to get, right, we are going to get it as v into ks sine 2 theta, right, ks sine 2 theta divided by 2 plus c sine theta. So these two formulas, right, is going to be important for us in order to solve the problem if we are going to have the angle of inclination, if we are going to have the line of sight, it is going to be inclined. Okay. Thus, by using the equation 1 and 2, d is nothing but ks cos square theta plus c cos theta, we can use, or we can determine the distance, right? We can determine the distance c, right? We can determine the distance, horizontal distance d, and vertical distance if we want, we will be using the formula ks sine 2 theta divided by 2 plus c sine theta. So these two formulas we will be utilizing it when we need to solve the problem. Okay, now we will see exact the elevation of the staff station for angle, right? We if we want the exactly the if we want the exactly the elevation of point q, how we are going to determine it. So q, if we want this particular q, right, if we want this height q, how we are going to determine it is we will be using the elevation of point p, that is this particular point, plus we will be having this h, right, we will be p, right, the your elevation at point p, that is your reading will be given to you, plus the height of the instrument will you need to determine. Then we will be finding out, so elevation of p plus h. Now what we want this particular point q, right, this particular we want the height, this particular height. So p plus h minus v and minus r. So p, elevation of point p plus h. So we are going to get height till this. Now, but what we want height till this. So it will become minus v and minus r. So minus v if we want, right, if we do, we are going to get the height till this, right? But what we want to find out the height of the elevation point q. So this is v minus r. So if we do minus r, we are going to get this particular height q from the point p, right? This particular, if we want the height q from the point p, we will be using the equation, right? Elevation of point p plus h minus v minus r. Is it clear? Is it clear?
Yes, sir.
Okay. So basically you need to remember two formulas, that is d is equal to ks cos theta, d is equal to ks cos square theta plus c cos theta, and v is equal to ks sine 2 theta divided by 2 plus c sine theta. In if you want to measure the horizontal distance and the vertical distance, and then this you can get it from the diagram. See, what is important in this type of a problem is after reading the problem, right, after reading the problem, you need to draw the problem in a very fine way, or you need to draw the problem, right, very accurately, then your problem will become easy. If you are going to do the wrong things when you are going to measure, and when you are going to do if you don't draw the your problem very fine, then what will happen, you will be going wrong in interpreting the things. So the important thing, when you are going to solve the problem, you need to interpret it correct, and you need to draw the diagram correct, then only you will be solving your problem in a very accurate way. Okay, now we are going to have, in this last problem, what we have done is we have kept this staff straight, right? Here in this problem, what we have done is we have kept this staff straight to the base. Now we will study one case where we will be keeping this staff. If we are keeping this staff in an inclined position, right, distance and elevation formula for the staff is going to be normal, that is inclined side. So we are going to keep, if we are going to keep this staff in an inclined position, our say formulas we are going to do, we are there will be the formulas, it is going to change. So now we will see what formulas we will be using, right, what formulas we are going to use, right, if we want to measure the distance d, and we are going to measure the distance v. Okay, so if we are going to keep, if the line of sight at an angle of elevation theta, right, here what is now S is equal to staff intercept, we already know it. S is nothing but that is AB, it is the staff intercept, right, we already know it. Then CQ is the axial, C and Q, it is the axial radial reading. Now with the same notations as in case of last case, that is your L is equal to, that is this this inclined line of sight will become Ks plus C, right? So the horizontal line of sight will become equal to D is equal to, right? D is equal to M, D is equal to MC dash, right? D is equal to, right? It will become M C dash, right? Because here we are going to have the line of sight M C dash, this what we want this distance. So M and C, MQ dash we want. Okay, so MC dash plus C dash Q dash. So here we want MQ dash, that is the horizontal distance. In order to measure that, what will be our equation? MC dash plus C dash Q dash. So what will be our equation will become L cos theta plus R sin theta. L cos theta into R sin theta. But we already know that L is equal to Ks plus C. So just we are applying L is equal to Ks plus C into cos theta plus R sin theta. So this is the formula that we are going to implement when we are going to place our line of sight in your staff into an inclined line of sight. Okay, now this is the formula we are going to use, right? Now in case of your inclined line of sight, that is your vertical distance, it will become equal to L sin theta. So L is nothing but it is already Ks plus C. So Ks plus C into sin theta. So this is how your equation is going to become. Okay, now we will see one more case. This is for your angle of inclination, right? If we are going to have our angle of declination, right, we call it as an angle of depression, right? If we want to have the angle of depression, right, our line of sight, so what we want the horizontal distance D. Again here we want the MC, we want D, the horizontal distance, here your length, right, your length will become equal to Ks plus C, that is MC, right? This is become equal to L is become equal to MC, right? So here it is again MC plus Ks plus C, but what we want the horizontal distance D. The horizontal distance is nothing but it is from M to the base, right? So it will become equal to, right? It will become equal to MC dash, right? MC dash minus C dash Q dash minus C dash Q dash. So our formula will become equal to L cos theta minus R sin theta. But we already know what is L is equal to Ks plus C. So here your equation will become equal to Ks plus C cos theta minus R sin theta. But here what it was? It was Ks plus C cos theta plus R sin theta. But here it will become minus. Okay. In place of your declination, your D will become equal to the same equation, but here it will become minus. Okay, minus R sin theta in case of your angle of declination. Okay, now vertical distance V will become equal to L sin theta. It will remain same. So Ks plus C into sin theta. But what will become your angle of elevation, right? Here, if your angle of declination is nothing but you are looking towards the side. So what we want to measure this, right? We want to have the height this. So it will become elevation of P, right? Plus H. So plus H. But here, if we do minus V, we are going to get the C till C value. Then if we do minus R cos theta, we are going to get the elevation. In order to get the elevation of Q, we will be using the formula elevation of P plus H minus V minus R cos theta. So this is what the formulas we are going to use, right? Here it is with the base, it is going to make an angle R cos theta, right? And with the base, it is going to make an angle R cos theta. So here also it is going to make an angle R cos theta. So here it is becoming, right? In case of your inclination, it will become, right, plus R cos theta. Here it is becoming, and then we are going to get minus R cos theta. So here, in case inclination, how we are going to measure it, right? Distance D is equal to Ks plus C cos theta plus R sin theta. But here it will become, right? It will become Ks plus C cos theta minus R sin theta. V will become equal to Ks plus C sin theta. Both the cases, it will become Ks plus C into sin theta. Okay, so this is what we are going to use when we are going to solve the problems. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
The thing what you need to do when we will be doing the problem systematically, in what cases we will be using which formula, that we will be noting it down, right? If the line of sight is in horizontal, right, I will use this formula, that is D is equal to Ks plus C. If it is if we want the K, when we are going to have, right, the horizontal line of sight, then K we are going to use this formula, d2 minus d1 divided by s2 minus s1, and curvature, your correction, right? We will be using the constancy, we will be using d2 s2 minus d2 s1 divided by s2 minus s1, right? These formulas we are going to use for horizontal line of sight. Then we will be using, if the line of sight is inclined, then we will be using the formula d ks cos square theta plus c cos theta. V is nothing but the ks sin 2 theta divided by 2 plus c sin theta we will be using, right? And then if it is inclined line of sight with having the staff inclined position, then we will be using the ks plus c cos theta plus r sin theta. Horizontal distance, vertical distance, L is equal to ks plus c sin theta we will be using. And again here, if the line of angle is in a declined position, then we will be using ks plus c cos theta minus r sin theta, that is a negative, and v is equal to L sin theta, L is equal to ks plus c sin theta. So here we will put it in a systematic format when we are before going to solve the problem in the next class. What we are going to do is we will be keeping the various condition, in what condition what formulas has to be used, that we will be keep systematically before solving the problem, right? We will write it systematically, right? Then we will be going to solve the problem, so that your things will become easy when you are going to solve the problem. Is it clear? Is it
Yes, sir.
clear? Okay.
Yes, sir.
So in your next class, what we are going to do is we will be writing down all these problems systematically, all these formulas systematically, right? For what case, which formulas we are going to do it, right? Which formulas we are going to use it. We will write systematically, and then we will be moving ahead with your problems. Please write your attendance in your chat box so that I will get an attendance, right? Is there any doubt? If any doubts are there, it will be clear to you when we are going to use or when we are going to solve the problems directly. Is there any doubt? Yes? Is there any
No,
doubt?
sir.
Okay. Then I think we will end the session over here, right? And for your internals, right? For your internals, what we shall do, we will be keeping, right? Whatever we have covered in today's class, till today's class, we will be keeping for your internal. We will be keeping the portion covered till today, right? We will be keeping for your internal. When is your advanced surveying internal? Is yes. When is your advanced survey internal? Anybody knows?